Hello. In my last video, I did not talk about the part where I wanted to generate sounds. My initial goal was to recreate a sound for the purpose of being able to represent a sound as a latent space. I don't know if that's the exact word for it, but what I've done is I've created an autoencoder. And the autoencoder, it takes in all of the wave file data. And it takes this wave file data and it compresses it down to just a handful of numbers. And then it takes this handful of numbers and I'm teaching it to turn it back into the original wave file. You might think that's compression, which is it's actually a lot more than that because the encoding process, it because of the nature of how it works, it keeps simplifying the data, so it is extracting the important features out of the data, out of the sound effect. Then these important features, it is then learning to take these important features and turn it back into the full representation of the sound. So now you have a two-way process. I can take a sound, extract what's meaningful out of it, and then whatever it considers meaningful, turn that back into the full sound with hopefully indistinguishable to human hearing levels of quality. But here's the issue. To generate new sounds out of this, which is what I want, I actually need to tell it how similar, I need to be able to understand how similar each sound is to the dataset. And you can't do that with a single sound. Because if you could conceivably make this tiny representation a point on a map, and then you put another point and you ask how similar are these two, you have no reference points. So what you are best off doing is getting a bunch of sounds. Let's just say 20 for now. Encoding them all into this tiny representation. Then taking all of the tiny representations and then learning another model that all of these points, and you're gonna see the pattern here, actually become like a shape. And so if you learn to turn random noise into a point within this shape, you can take a random point, conceive of that as a new set of features, and then take it into the decoder. And because you've already learned it how to convert features back into sound, create a new variation of the existing sound. To do that, you must first actually be able to train an autoencoder to take in a lot of sounds, which I have here. And still create the original sound back, which I have achieved today. You can see here, this is the reconstruction. It's just exactly the same as the original dataset file. I don't know which one it was because I haven't labeled it, but so I kind of lost track of where I was saying, but once you are able to create an autoencoder that can encode and decode, you can then encode all of the dataset files, train another model to convert noise into something within that space, then take a point within that space and use the autoencoder to generate a new sound. This is how most of the image generation tools actually work online, except they're much more complicated. They probably have very huge data sets and a lot of engineering involved, but fundamentally, there's not much creativity in AI. They want you to believe that there is, but creativity really is just being able to apply new concepts to other areas. But what this fundamentally does is it tries to quantify a set of data, and then it tries to create a piece of data that sort of has features of things in between it. So I take this point, but this point kind of has something more similar to this dataset file, to this dataset file, and to this dataset file, but it's not unique. It's not unique because we already trained this autoencoder to be able to turn features back into sound. And so this really is just a set of features, and we trained a model to give us a feature set that's valid, that is within the shape, such that we can kind of interpolate between it. Kind of. This is a bit of a simplified version of how it works, but now you can start to understand why uh, generation really is not unique and actually very predictable if you know the data sets and if you know the way it's generated. But at the end of the day, for the purpose of generating variations of specific sounds, this is absolutely perfect.